A company has 5 employees on its health plan. Each year, each employee independently has 80% probability of no hospital. If an employee requires one or more hospital admissions, the number of admissions is modeled by geometric distribution with mean 1.5. The numbers of hospital admissions of different employees are independent. Each admission costs 20,000. Calculate the probability that the company's total hospital costs are less than 50,000. So the first thing to note is that since we want the probability of total cost to be less than 50,000 and each admission is costing 20,000, so what that means is that we actually want the probability of 2 or fewer admissions, because if there are 2 admissions, then the cost will be 40,000. That is still less than 50,000. But if there are 3 admissions, then the cost will be 60,000, and that becomes more than 50,000. So the probability of less than 50,000 total cost is a roundabout way of saying that find the probability of 2 or fewer admissions, 2 or fewer total admissions. So now the next thing is that the number of admitted employees. So there are 5 total employees, and the number of admitted employees, admitted means admitted to the hospital, is binomial. N is 5 because there are 5 employees, and P is 0.2 because we are told that there's 80% probability that an employee will not be admitted. So what that means is that there'll be 20% probability that the employee will be admitted. So that's why we're calling P as 0.2 and calling the success in this case as being admitted. So then we use our binomial formula and we get 5cx, 0.2 power x, and 1 minus 0.2 is 0.8. So 0.8 power 5 minus 6. So now once an employee is admitted, then the number of visits is geometric with mean 1.5. That's what they told us. Yeah. If an employee requires an admission, then the number of admissions is geometric with mean 1.5. So we know that for a geometric distribution, this is the main formula. One, I'm using a big P because the lowercase p I'm using for the binomial success probability. So I'm using uppercase P for the geometric success probability. So we know that this is the formula for geometric distribution, 1 minus P power V minus 1 times P. And we are told that the mean is 1.5, but we also know that the mean of a geometric distribution is 1 over P. So it means 1 over P equals 1.5. So P will be 1 over 1.5, and that will be 2/3. And therefore, we can, when substitute this P in this formula, we get GV equals 1 minus 2/3 power V minus 1 times 2/3. And that simplifies to 1/3 power V minus 1 times 2/3. And from here, we can see that G of 1 is 2/3, and G of 2 will be 2/9. Now, the reason why we only calculate G of 1 and G of 2 is that in the problem, remember, we have to find the probability that there will be a total of 2 or fewer admissions. So we're not interested in anything more than 2. Okay, so we just make a note of these. We'll need these later. So now the main question, remember, boiled down to finding the probability that there are 2 or fewer total admissions. Now this can happen in the following scenarios. Case 1, no employees admitted, then obviously we have 0 admissions, which is 2 or fewer. So the probability of this can be found by substituting x equals 0 in 1. Remember, 1 was giving us the number of admitted employees. And here we are dealing with the case that the number of admitted employees are 0. So f of 0 comes out to be this. And that's one of scenario in which we will have 2 or fewer admissions. And that's no employees admitted, and the probability of that is 0.32768. Case 2 is that one employee goes and has one admission only. One employee goes means that during the year only one employee ever gets hospitalized. Others never go. And so we don't we remember our main goal is to find the probability of total visits being 2 or less. So even if there's only one employee going, that employee may have multiple visits. So we want one employee to go and have one admission. That's case 2, in which the total admissions will be 2 or less. So the probability of one employee going and having only one visit will be, so the one employee going is f of 1. Remember that f was the binomial that was giving us that how many employees go, and means multiplication. One visit would be g of 1. G was giving us the number of visits once an employee goes. And so we substitute 1 in the binomial formula. And remember, we calculated g of 1 to be 2/3. So we substitute that now and get 0.27307. Case 3 is one employee goes and has 2 admissions. So that's also fine, because it's still going to be less than or equal to the 2 admissions that we want total. Others never go. So this will be the case where one employee goes and has 2 visits. One employee goes is f of 1 and 2 visits is g of 2. Okay, and g of 2 we found above was 2/9, and f of 1 again is found from the binomial formula. So this one is 0.09102. And then the last case is that 2 employees go and each has 1 admission. So in this case also the total admissions is 2, which is 2 or less. Others have none. And so this would be 2 employees go, first has 1 visit and second has 1 visit. So there are 2 ands going on here, this and this and this. So 2 employees go is f of 2. First one has 1 visit is g of 1, and second one has 1 visit is g of 1. Okay, 1 visit is g of 1 in each case. So in this one, when we substitute 2 in the binomial and then g of 1 times g of 1, so this one is also 0.09102. And so these are the only 4 cases in which we can have 2 or fewer admissions. And the total probability of 2 or fewer admissions is found by adding the probability of all these cases, because these are all the cases and they're all mutually exclusive. So just add that there's no overlap between these 4 cases. So the total probability will just be the simple addition of these. So this, and this, and we add them, it's 0.78. That's choice E.